Right, carrying on with 11.3, page 184185. We're looking at question 4, calculate the total surface area of these cuboids. Now, you may remember from previous vids that we have in fact got 6 surfaces, 6 rectangular surfaces. That should be a dotted line really, there you go. Hope you can see 6 rectangles there. So we've got a 4x3 at the front and a 4x3 at the back. So total surface area, I've got 4 by 3 by what's that? I've got 2 of them, haven't I? So 4 by 3, and I've got 2 of them, one at the back, one at the front. So that's going to be 24 centimeters squares of area. Here I've got an 8 by 3. So I've got an 8 by 3, and I've got 2 of them. And there's that one, and there's that one there. That's 24 times 2, 48 centimeters squares. And I've got the top and the bottom, which will be like an 8 by 4 or 4 by 8, and the top is also 4 by 8. So I've got 2 of those. So 32 doubled up, 64 centimeters squared. So the total surface area is going to be 24 plus 48 plus 64. Obviously don't set it out as sloppy as that. 136 centimeter square surface area. Let's just do this one quickly, we'll move on. If you imagine we got something like that, hope you can see the 6 surfaces. It's crudely done, but that's essentially 6 surfaces. We've got no mixed units, all in millimeters. The answer will be in millimeters squared when we do the surface area. We've got 5.5 by 18, so make it fit here. 5.5 by 18, that's the bottom. And of course there's one at the top as well, so let's just double up on that one. Hopefully that will fit. 5.5 times 18 times 2, that gives us 198. Of course that's millimeters squares. I've got 18 by 22, this large surface here, and of course I've got 2 of them because that's this one back here as well. Oops, made a little mark there, never mind, doesn't affect the maths much. So work it out. 18 times 22, and I've got 2 of these. 792 millimeters squares, and I've done that one. Let's look at this one at the front. That's going to be 5.5 times 22, and I've got 2 of those as well. So 5.5 times 22 and 2 of those, 242. Must get the total surface area. Add up that little lot there, that's millimeters squares of course. Okay, add that little lot. I've got a 198, I've got a 792, and I'm going to add on a 242 as well. That gives me 1,232 millimeters squares of surface area. Now I want to highlight an error in question 4b. Now it's an error by this textbook. You can actually calculate the total surface area of these triangular prisms. Now look, the front face here of this triangular prism has an area of 8 times 9, and then you halve it, half base times height. But if I want to work out the area of this rectangular face here, I have to go 15 times, but I don't know what this slanted length is. Now you may recall from Key Stage 3 that you can work out the slanted length using Pythagoras. The trouble is we're now in chapter 11, and Pythagoras is the very last chapter of unit 3, chapter 18. So this is in fact a very unfair question, because you've not experienced or come across Pythagoras yet in this final unit of year 11. So I think it's a mistake on the part of this textbook here, AQA Mathematics Unit 3 Foundation Series. It's a mistake. I think these questions should have been saved, you know, way for later. Save it for chapter 18 really. But I'm going to do it now based on your Key Stage 3 knowledge. So look, right angle triangle. So what I've done is copied this page on the other side, and if we look at it carefully, let's just work out this length right here. Let's call it x, and if that's x and that's 9, then this part must be 4 because it's half of the 8, isn't it? Alright, so I've got a triangle that looks like this. I've got a height of 9 millimeters. I've got a longer slanted length of x, and I've got a half base of 4 millimeters. Now, using Pythagoras, see if we recall this, x squared equals 9 squared plus 4 squared. That makes 81 plus 16. That makes 97. So to get x on its own, you press the square root button on 97. It's got to be done. So 97 square rooted gives me, let's go 2 decimal places, 9.85 millimeters. Alright, so the length that I want is 9.85 millimeters. Now I'm free to work out everything. Don't know if you can tell from here, I hope I don't mess up the diagram too much, there's actually another triangle at the back there. I won't fully draw it in because it's going to crash into our answer, isn't it? So essentially I've got 2 triangular faces, one at the back, one at the front, and I've got 3 rectangular faces. Well, I've got this one that goes 9.85 by 15, this one's going to be 9.85 by 15, and the bottom one is just 8 by 15, very easy. So let's work out the triangular face. That's going to be half base times height, half times base times height, and of course I've got 2 of them, one there and one there. Okay, half times 2 is just 1, 9 eighths is 72, 72 millimeter squares. We'll do a bottom rectangle. We then have, we may as well call it bottom rectangle since I've said it. That's going to be 8 by 15. Get my machine on that one. 8 by 15 is going to be 120. So an extra 120 millimeters square. And it's going to be the larger rectangle, this one. I've got 9.85 multiplied by 15, and I've got one at the back as well. Alright, that's that one. So I just multiply it by 2. In fact, I might as well call it triangular face areas and larger rectangles, plural. That'll be alright. So 9.85 times 15 times 2 of them. I've got 295.5 millimeters squared. Hopefully I want to get the total area. So let's just highlight the bits that I need. If I go in blue, I need that, I need that, and I need that little bit there. Alright, add up those 3 numbers, so 72 plus 120 plus 295.5 approximately will give us, so 72, add on 120, add on 295.5. So total area, I don't know whether it's supposed to be like, well, I know the answer is correct. What I mean is, I don't know if we were supposed to use Pythag and they'll pull a fast one on us, or whether it's a complete oversight on the part of those who produced the book. So the final answer is 487.5 millimeter squares of surface, so that's that. Now with that in mind, I'll try and squeeze the working for this one as well. And again, we have to use Pythagoras. We need to know this length in order to work out the area of this rectangle here. So let me just draw how it looks if you had a 3D arrangement. So we're sort of going in like that. Let's draw a dotted line coming down freehand and join these 2 vertices with a dotted line. Okay, so I've got a triangular surface at the front, one at the back. I've got rectangle on the floor, 11.2 by 4, and I've got a rectangle here at the back which is 7.4 by 4. So if I put a 4 there in black, then we can perhaps use that later. So I've got 7.4 by 4, 11.2 by 4, and I need to know this length to work out the area of this larger rectangle. Alright, so let's go Pythagoras again. Again, we'll call this long side x. So here we go, x squared equals 11.2 squared plus 7.4 squared. So 11.2, squared, that is 125.44 plus 7.4 squared, 7.4 squared, 54.76 altogether, plus 125.44 from last time, gives us 180.2. So to get x on its own, we press the square root button, 180.2. Let's just root that now. That comes to 13.42. It makes sense, doesn't it? Because obviously the longest side got to be bigger than the 11.2. So x is in fact 13.42, and now we're in centimeters as opposed to the millimeters on this side. Right, we're ready to rock and roll. Area of this triangle here, half base times height. So let's just jump. I won't use any words. Just jump straight in. Half times base times height of 7.4. And I've got one at the back as well, so I'm going to double up. Just get that. That'll be 11.2 times 7.4. That will give me 82.88 centimeters square. That's the triangle's done. The rectangle on the floor is 11.2 by 4. So I've got 11.2 by 4 comes to 44.8 centimeters squared. That's got one done. The one at the back is 7.4 by 4. Meant to be 2. So 7.4 by 4, 29.6 centimeters squared. And finally the big one, 13.42 by 4. So 13.42 times 4, bam, I've got 53.68 centimeters square. So now I'm going to call it total surface area is going to be, well, I'm just going to highlight it. I don't think I've got a lot of space to write out the three or four numbers though. So I've got this, my triangles, I've got my three rectangles, that one, and that one, and they're all different of course. 11.2 by 4, 7.4 by 4, and this 13.42 by 4, and that's that one. Let's just get that little total in blue. So I'll speak what I'm adding in, by the way. 82.88, add on the 44.8, add on the 29.6, and add on the 53.68, I think it says there. Yeah, that gives me 210 point, sorry, 210, not 201, 210.96. I want to call that 211 centimeters squares. Obviously if I round it off to 1 dp I can't. That will push this up to 0, and that will become a 1, so that's fine. 211 centimeters squares. And if that's the answer at the back of the teacher's book then, and in your answer book, then great, we're supposed to use Pythag. I suspect they forgot to give us a slanted length here and a slanted length here. Would have helped enormously. And but anyway, we had to use Pythagoras. And I think I'll pause that, 'cause that's been quite long, and it's a lot to take in. So you have to revise your Pythagoras ahead of schedule. We'll meet it in chapter 18. But until then, here's some fancy revision, and I hope you've enjoyed it.